All right, guys, a question was asked about the 10-3 worksheet, problem number 1, so I thought I'd work through that with you guys. They tell you in the directions here that you're dealing with a regular polygon, and there's a radius and an apothem that's shown, and we're supposed to find the measure of each of those numbered angles in this figure right over here. So the first thing you probably want to figure out is how many sides we're dealing with in each particular one of these polygons. And in number 1 here, you can count them up, see quickly here that we are dealing with a regular octagon, which means we have 8 sides. Now what they're asking you to find right here for angle 1 is what we in the notes call theta, which is the measure of a central angle. So if you were to count up the number of central angles that you have, it's always the same as this value of n here, and theta, the sum, the measure of each one of those central angles is going to be found by taking the sum of all of them. And if you were to add up all 8 of those central angles, you'd see that it makes a complete circle. So that sum is going to be 360. And we're going to divide that by the number of central angles that we have in each case. And that's going to tell you the measure of theta. So the 360 divided by 8, if I'm not mistaken there, is, let's see, 180, 90 is going to be 45 degrees for the measure of each central angle. So that is going to be the measure of angle 1, and that's the first thing that we were supposed to come up with within this problem. Let me get rid of some of my markings right here so we can see that a little bit more clearly. Okay, then from there we were supposed to come up with the measure of angle 2 and the measure of angle 3. Well, the measure of angle 2, this little guy right over here, is going to be half of the measure of that central angle because the apothem that was drawn right down the middle of that isosceles triangle on the bottom always bisects the central angle. So the measure of angle 2 is going to be your answer for the measure of angle 1 right here, which is 45 degrees, and then we're always going to divide that by 2 because the apothem bisects that central angle, and we end up with 22.5 degrees. So that's going to be the measure of angle 2. And then, if we're trying to figure out the measure of angle 3, what I'm going to do here is kind of highlight this triangle that we have here, and then I'm going to redraw it over on the side a lot bigger so we can actually do something with it. All right, so in this triangle here, which is formed by drawing an apothem here and a radius right here, and this piece down on the bottom, which I usually call x, it's half a side length. Well, let's think about what we know. We know that we have a right angle right here, because the apothem is always perpendicular to the side it's drawn to. We just found that the measure of angle 2 was 22.5 degrees, so if we want to come up with the measure of angle 3, we just need to take advantage of the fact that in every triangle, the sum of our 3 angles is 180, or in a more advanced way, that's actually easier that I'd like you guys to start thinking about, in every right triangle, the 2 acute angles always have to be complementary, meaning they add up to 90. So the measure of angle 3 is going to be formed by taking 90 minus the measure of angle 2 that you came up with in the second part of this. And that 90 minus the 22.5 is going to get us a 67.5 degree angle for the measure of angle 3. And problem 2 and 3 really work in the exact same way. The only thing different there is that n is going to be different in each one of those problems.